The James Webb Space Telescope, humanity's most powerful and advanced space observatory, is revolutionizing our understanding of the cosmos. Launched into space in December 2021, JWST now orbits the Sun nearly 1.5 million kilometers from Earth at the second Lagrange point, far beyond the Moon. There, it peers into the deepest reaches of the universe, equipped with a massive gold-coated mirror and finely tuned infrared instruments capable of detecting the faintest light from the earliest galaxies, the atmospheres of distant exoplanets, and the chemistry of alien worlds. And recently, this remarkable machine turned its gaze toward a planet orbiting a small star more than 120 light-years away. What it discovered has stunned scientists, reignited the search for life, and raised provocative questions about humanity's place in the cosmos. That planet is K218b, a sub-Neptune world orbiting a cool red dwarf star in the constellation Leo. Though not located in our solar system, its conditions place it within the habitable zone, meaning it's far enough from its star to avoid boiling, but close enough to potentially allow for the presence of liquid water. For decades, this so-called Goldilocks zone has represented the best shot for finding alien life, as water is considered a prerequisite for biology as we know it. But K218b is no ordinary planet. It's 2.6 times the size of Earth and almost 9 times as massive, with a thick hydrogen-rich atmosphere and signs that have left scientists breathless with excitement. Using its near-infrared spectrograph, NIR-SPEC, JWST detected carbon-bearing molecules in K218b's atmosphere, including methane and carbon dioxide, but surprisingly, almost no ammonia. This ratio of gases is what scientists would expect if the planet has an ocean beneath a thick atmosphere, possibly a Hycean world, a theoretical class of planets proposed just a few years ago. Hycean is short for hydrogen ocean, meaning such planets might have vast oceans of water wrapped in a hydrogen-rich envelope. These types of planets could be much more common than previously believed, and could dramatically expand the number of worlds capable of supporting life. But it was the possible detection of dimethyl sulfide, DMS, that truly raised eyebrows. On Earth, DMS is only produced by life, mostly by phytoplankton, tiny, microscopic marine organisms that form the base of Earth's food chain. No known geological or non-biological process produces significant amounts of DMS. If confirmed, the presence of this compound in K218b's atmosphere could be the first direct biosignature, a chemical fingerprint of life, detected beyond Earth. However, this result is tentative. The JWST data is still being analyzed, and astronomers are being cautious not to jump to conclusions. But even the suggestion of such a molecule has electrified the scientific community. To appreciate the significance of this moment, consider that for most of human history, the stars were little more than distant lights in the sky. Even as telescopes improved, planets outside our solar system, exoplanets, remained theoretical. It wasn't until the mid-1990s that the first exoplanet around a Sun-like star was confirmed. Now, just 3 decades later, we're not only detecting exoplanets by the thousands, we're analyzing their atmospheres, breaking down their molecular composition, and pondering whether life may already exist on some of them. JWST's power lies in its ability to detect transmission spectra, the way starlight changes as it passes through a planet's atmosphere during a transit. As K218b passed in front of its host star, some of that starlight filtered through its atmospheric gases, imprinting spectral signatures that the telescope could detect. It's like reading the chemical recipe of an alien sky from more than 100 light-years away. And what that recipe suggests is astounding. The potential for oceans, clouds, and climate systems, perhaps even rainfall, on a planet light-years from Earth. But K218b's atmosphere might not be the only place where biology could thrive. Beneath the thick gaseous envelope, if a liquid ocean exists, it could be sheltered from stellar radiation, creating a relatively stable and life-supporting environment. Life on such a planet might not look like anything we're familiar with. It could be microbial, aquatic, or even entirely alien in its biochemistry. But the presence of key molecules suggests that prebiotic chemistry, the kind that led to life on Earth, might already be active. Yet this discovery is only part of what JWST has been uncovering. In another distant galaxy, scientists recently observed something even more ancient and profound: the detection of polycyclic aromatic hydrocarbons, PAHs, in a galaxy known as SP41847, which existed just 1.5 billion years after the Big Bang. These complex organic molecules, found in substances like coal and soot, are also associated with the formation of life on Earth. Their presence in such an early galaxy challenges previous assumptions about how quickly the chemical precursors to life could emerge in the universe. Even more intriguing is the irregular distribution of these hydrocarbons within the galaxy. Unlike the even spread expected in young star-forming regions, the molecules appear in clumpy, unpredictable pockets. This raises questions about how early supernovae, black holes, or turbulent stellar winds might have seeded complex organic materials throughout the early universe. In other words, the building blocks of life may not be a rare occurrence. They might be woven into the very fabric of the cosmos, emerging again and again as galaxies form and evolve. The James Webb Space Telescope is not just searching for life. It's also reshaping how we understand planetary systems, stellar nurseries, and even the origins of the universe itself. It has provided never-before-seen views of the pillars of creation, massive columns of gas and dust where new stars are born. It's revealed the chaotic disks of young stars, showing how planets form and migrate. It's mapped the atmospheres of gas giants, discovered rogue planets drifting alone through interstellar space, and even spotted light from the first galaxies, shining across billions of years to reach us. JWST has shown us that time and distance are no longer barriers. We are now capable of observing galaxies as they were over 13 billion years ago, giving us a glimpse into the early formation of cosmic structures, into the first stars that lit up the universe, and possibly into the origins of chemistry that eventually gave rise to life. With every observation, we are narrowing the gap between speculation and evidence, between asking, "What if?" and declaring, "What is?" But perhaps the most profound implication of all this is what it means for humanity's future. If life is discovered, whether microbial or complex, whether on K218b or another world, it will be the most important scientific discovery in history. It would mean we are not alone. That biology is not unique to Earth. And that the universe is not a sterile, silent void, but a living, evolving ecosystem, rich with possibilities and perhaps even civilizations. This changes everything, not just science, but philosophy, religion, culture, and the human self-image. It forces us to ask deeper questions. How common is life in the universe? Is intelligence rare or inevitable? Could civilizations have risen and fallen long before us, their signals swallowed by the expansion of space? Could we one day meet them, or become them? These questions once belonged to the realm of science fiction. Now, they are active scientific investigations, made possible by the tools we've built and the will to explore. The James Webb Space Telescope is not simply a machine. It is a monument to human curiosity, a sentinel of our civilization placed in the void to watch and learn and listen. And in doing so, it reflects something beautiful and timeless about us. That no matter how far the distance, how dark the night, we still search for the light. At Wave's Discovery, we will continue following this story, and the countless others JWST is yet to reveal. Because the greatest discoveries of our time are still unfolding. And with each passing day, we draw a little closer to answering one of the oldest, most enduring questions of all. Are we truly alone in the universe? Make sure to like, subscribe, and turn on notifications so you never miss an update from Wave's Discovery. Join us as we journey deeper into space and closer to understanding the mysteries that surround us, because the universe is calling, and we are finally ready to answer.